Okay, so in this video, we're going to cover everything that we've talked about. We're going to graph our polynomial, so make sure you got your calculator ready. We're going to find the local max and local min using our calculator. We're going to find the intervals of increasing and decreasing. We're also going to describe the end behavior. So in order to do 3, we need to do 2. The end behavior we can't actually get by looking at this in standard form. So the first thing I'm going to do is I'm going to rewrite this equation in standard form. I notice that it is going to be negative x to the fourth plus x cubed plus 4x squared minus 3. So this guy is a quartic polynomial. Okay? So it's a quartic polynomial, so that's how we would name it. Because it's quartic, it's an even function because the degree is 4. That's the largest exponent in the polynomial. Because it's even, I know that the end behavior is going in the same direction. And then so because the negative, I know that it's going to open down. So I know, even though we're going to save this to the very end, but that is one of the ways that I can just find the end behavior. So we'll go through it, we'll graph it, and we'll talk about the end behavior with the graph also. But I wanted to point that out, that number 4 can be done right away. So we're going to go ahead and graph this guy. So go ahead, pause the video, graph it on your calculator, and confirm that what you get on your calculator is the same thing that I have drawn. Okay, so this is the general picture for our for our quartic polynomial. And we're going to locate this. We're going to locate our local maxes and our local mins. So notice, because it's quartic, I have 3 turning points. I have this guy, and this guy. And our turning points are going to be our maxes and our mins. So this guy right here is a negative 0.96, negative 1.05. So we'll call this guy A, we'll call this guy B, we'll call this guy C. It's kind of hard to read on the image, so I'll put it over here to the right. Okay, and so you'll see here that we have A, B, and C, and I've identified A, B, and the coordinates of A, B, and C. So this guy right here is a max, this guy is a min, and this guy is a max. Okay? So we've approximated all of our maxes and our mins. It's said to the nearest tenth. My rounding is off. I round to the nearest hundredth, but that's fine. We'll go ahead and round to the nearest tenth. So technically, this guy should be a negative 1.1. And this guy should be a 5.2. This guy should be a 1.9. And this guy should be a negative 1.0. Makes life a little bit easier when we're labeling points and intervals. Okay, so now let's do a little bit of our interval work. So we're going to start left to right. So I know that over here is negative infinity. So as I go from negative infinity up to point A, so this is an increasing interval. So I am increasing from negative infinity all the way to negative 1, point A, the x value. So my x's, when they are in between negative infinity and negative 1, the y values will be increasing as I go from left to right. Okay? The next interval is going to be from A to B. And as we read, and I just put it in green here, as we read from A to B, it's decreasing from A to B. Okay? And so to write that interval, I take my x coordinate, I take my b x coordinate, and I know when x is between those two values, I'm going to be decreasing. Okay? So the next interval is going to be from B to C, and I'm going up. So I'm going to be increasing from B to C. And so that interval, we write it using our x values, is going to be from when x is greater than 0 but less than 1.9. And last but not least, we have from C, and because of the arrowhead, this is positive infinity. It's decreasing from C to positive infinity. I apologize, this should have been a C right here. From C to positive infinity. So that means when x is greater than 1.9 but less than infinity, the graph is decreasing. And so what I've found here going from left to right, sorry about that, is our intervals. So this is number 3, and number 4 is our end behavior. And simply our end behavior is what's happening at the end of the graph. It's falling to the left and falling to the right. And so we just use arrows to point in those directions. So this is one example that covers all of the things that we've done in this section. And so you'll see bits of problems on quizzes and tests, or a problem completely like this where you have to find everything and put it all together.